Hello everyone, this is Calculus 3. So in this video, we're going to talk about the last unit in chapter 3, 3.4, motion in space. So we have now seen how to describe curves in the plane and in space. And also we learned how to determine their properties such as arc length and curvature in the previous unit. So all of these concepts lead to the main goal of this chapter, which is the description of a motion along plane curves, and it's a space curve. So now we have all the tools we need. So in this section, we're going to put all these ideas together and look at how to use them. Okay, so our starting point is using vector value function to represent the position of an object as a function of time. So what I'm saying is, for example, when you look at the orbit of the planets, the curves defining these orbits all lie in a plane because they are elliptical. So the position, if you remember in calculus 1 and 2, there is a position function. And if you take the derivative, you can find out the velocity function. And if you take the double derivative, you can find out the acceleration. We are doing the similar work because your object is moving in the space. It could be orbit or it could be any object in three-dimensional space. You can find out the position function, and by taking the derivative, you can find out the velocity and acceleration. So we're gonna use, because this is a curvature, this is a vector, so we have all the tools that we're gonna find out that information. So let's take a look at the next slide that I'm gonna show you all that things, okay? So we're gonna apply the concept of tangent vector, normal vector, and curvature to find out the velocity, acceleration, or other space curve information along the line. Okay, so let's take a look at it. Let's take a look at the concept. It's not something new. It's pretty much the same thing we learned in the previous unit or in calculus 1 and 2. So what happened is, if you take a look at it, the velocity, we are taking, I'm going to change the color. You're going to begin with the position function. So I'm going to show you two things. One is a 2-dimension, another one is a 3-dimension. So you have a 2 components in 2-dimension as a position function, or you have a 3 component as a vector in 3-dimensional space. By taking the derivative, you can find out velocity, 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 velocity. By taking double, you can find out the acceleration of the vector or of the motion. We are talking about the motion. This is a motion formula in space. And then if you take the magnitude, that's going to be the speed of 2 and 3-dimensional space. So the concepts are pretty simple. We are talking about the space in calculus 1 when you're dealing with the velocity, speed, acceleration. We are talking about one variable function, but now we have a vector. You have a vector is a following, like it could be a roller coaster. They're moving around. It's not the linear. It's like a vector line. This line is created by vector. So one is from the x-axis, another point is from the y-axis, another one is from the z-axis. We are dealing with the space. So therefore, if you take the derivative of the r vector, that means the velocity. If you take the double, if you take the, actually there's a missing double, and then that's going to be the speed, so which is here. And then actually I have a little bit of typo. There's a no. So vector magnitude, so from once you find out the velocity, and then take the square of it and then put the radical, that's the speed. So this formula is correct. And then acceleration is a double prime of the r vector. So you can find out r vector, velocity, and acceleration, and take the second power with the radical, that's the speed from the velocity function. So let's take a look at example 1. Your vector is a given, and I want to find out velocity, speed, acceleration at t equal to 1. Velocity, that is vt equal to r prime. So we can take a derivative of the r, so 3t second, 2t, and 3t second. So that's your velocity at t equal to 1. So velocity 1 will be 3, 2, 3. Correct? And then now you can find out we found out the velocity, find out the speed. The speed is what? Magnitude of the velocity. So we are going to, you can find out, this is at t equal to 1. So 9 plus 4 plus 9. So radical 22, this is a speed. Last one, acceleration. So this is a double prime, r double, that's a. So therefore, you're going to take the double from here. So r double prime will be 60 to 60. And then when t equal to 1, you can find out 6 to 6. So that's all the information you can find out, simply velocity, speed, and acceleration in the space. Okay. All right, one more example. So that was a warming up. Same question, I'm giving you different functions. So in this time, we have 2 components, but same thing. So I'm going to write it all vector is t to the second radical 5 minus t to the second. In other words, this is a t to the second 5 minus t to the second to the half exponent. So that's why you can find out the r prime much easier. So r prime will be 2t 1 over 2 5 minus t to the second 1 over 2 minus 1. So that's a 2t 1 over 2 5 minus t second negative 1 over 2. So this is the acceleration vt by taking one derivative. They didn't give you specific t value, so leave it like that. How about the speed? We are going to magnitude of the velocity. So that would be 2t second power 1 over 2 5 minus t second negative 1 over 2 second power. So that's going to be 4t to the second plus, you're going to distribute property 2 here and here. So then it is going to be 1 over 2 to the second 5 minus t to the second. They're going to cross negative 1. So it's not vector. This is the magnitude. So once we calculate it, it is going to be 4t second plus 1 over 4. Am I correct? And what else? Did I calculate correctly? Oh, did you notice something that I made a mistake? Here we go. You see that? I didn't use a chain rule. That's why there was something. So when you're taking the derivative of this, use the chain rule. There's one more, 2t. 5 is going to be 0. T squared is going to be 2t. So that is going to be actually velocity. And then we have to take the second power. So let me redo it from there. So let me get rid of it. So here, I'm going to just find out the acceleration again. So that is going to be 4t squared. And I can simplify 2 and 2 cancel. So velocity 2t 5 minus t to the second negative 1 over t. This is actually velocity, which is a better form. And then you can rewrite it 2t t over 5 minus t to the second half exponent. So I can change that negative exponent to the positive. Now let's do the speed. So let me make a space. Uh-oh, not that area. So let me make a space under here. So I'm going to bring this one speed. So now we're going to find out the speed function. Speed will be, we have 2t and then t over 5 minus t to the second half, and you're going to have a second power with the radical. So that's a summation. And then 4t to the second plus, you have a 2 here and there. So that is going to be t second over 5 minus t to the second to the 1, right? That's it. So we have this information. So I want to try to combine them by finding the common denominator. So we have a 4t second. There's invisible 1. So you're going to multiply 5 minus t to the second, 5 minus t to the second, top and bottom, t to the second over 5 minus t to the second, so that you can have the common denominator. So that would be, I'm going to use a distributive property. So 20t to the second minus 4t to the 4 plus t to the second over common denominator 5 minus t to the second. Gotcha. So therefore, if I simplify 21t to the second plus, actually minus 4t to the 4 over 5 minus t to the second. That's the acceleration. Are we okay with that? So this is, sorry, this is a speed. This is a speed. We have to do one more. So this is the velocity. Let's do the last one, acceleration, double, right? We are going to take the double integral, double derivative of the r vector. So you have to do, or that means the velocity, derivative of the velocity function. So we have a velocity right there. So let me copy this, copy. So we are going to take the derivative. So v prime, this is a 2, and you have to think about this one. This is t times 5 minus t to the second negative 1 over 2. So what happened is, this is the product rule. F is a t, f prime is 1, g is a 5 minus t to the second negative 1 over 2, g prime, we need a space. So g prime, I'm gonna get rid of it. So let me just, no, okay, let me minimize it. So we have that. And then g prime will be negative 1 over 2, 5 minus t to the second, negative 1 over 2 minus 1, chain rule, negative 2t. Okay? So therefore, g prime, negative 1 over 2, 5 minus t second, minus 3 over 2, 2t, 2 cancel. So g prime, negative 5 minus t to the second, minus 3 over 2t. Got it. Okay. So I'm going to double check. So there was a negative. So negative, negative. So my mistake, negative, negative changed to positive. So now you have, I'm not done yet. We have to find out the acceleration. So we are going to do f prime g, g prime f. This is only derivative of the second component. So f prime is 1, 1 times g is 5 minus t second, negative 1 over 2. G prime, we got 5 minus t second, negative 3 over 2 t times f, which is a t. So it's going to be t second power. So let's see if I write correctly. So we have, let me double check if my calculation is everything correct. So we have t velocity. Let me double check. So 5 minus, yeah, I think we got the correct number. So we have a little bit of, let me double check. I have a little bit of typo, sorry guys. In the chain rule, it's gonna be negative 2t. You see that? So there's a negative. So there's just put the negative there. So negative, we have a negative. So you're gonna get negative t. But anyway, this is gonna be t squared. And we have a minus t second. That's good. And then here we have a negative t. So that's a little bit of typo. Sorry about that. So we have t is, f is gonna be negative t, right? So the f is gonna be negative t. So f prime will be negative 1, my bad. That's it. That's all you need to change. So f prime is negative. So here negative. And then we have a negative t. Okay. And then we have t right there. So this is, let me double check. F is a negative t, f prime negative 1. G and g prime, we have, yes, 5 minus t. And then we have that information. Good, good. G prime is correct. So g prime, we got the correct number. But then let me just double check if I have any mistake here. Let me try it again. Sorry about that. So let me just try F, because the once I have a mistake, negative, we have all the mistakes. So let me just double check. We have F is a negative t, F prime negative 1, G is 5 minus t second negative 1 over 2. So minus 1 over 2, da 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 da. Yeah, that's a so far so good. So negative 2t. Yes, I think I'm good. I'm good here. And f prime g, so negative 1 times g. Yeah. So we have negative. So f prime is a negative 1 times g. Okay, that's good. Plus g prime, which is that. So there's no negative, right? This is f prime. And then g is negative t. So right there, there's negative. So now we can finalize it. So negative 5 minus t second, negative 1 over 2. And then minus, because of here, minus t second, 5 minus t second, negative 3 over 2. This is the second component derivative. Am I correct? So this number is going to be here, the second derivative. Okay, so that's the acceleration. So if I write it, all the number correctly. So let me just minimize it. So therefore, the acceleration, we took the derivative of the velocity. We got 2, and I'm going to flip over everything. So you should get the second one minus 5. Actually, minus. We have negative 1 over radical 5 minus t second, because I flip negative to the positive, minus we have a t second, and you have 3 radical 5 minus t to the second. So actually here, my bad, this is a third. This is going to be the second. You don't need to change this way, or you can just leave it here. That's fine. So this is the acceleration. Okay. So I don't think this is a challenging. Just when you're taking the derivative, we always need to know the techniques of derivative, like a product rule or quotient rule. So think about it when you have a little complicated function. So we found out the velocity here, speed here, and acceleration right there. This is acceleration. Okay, so that's all about it. So 3.4, it's not complicated at all. You can practice this one. So like I did, find out the velocity, acceleration, speed with the given, function. And then if you have acceleration is given, then take the, right? So R, and then R prime is going to be velocity. R double prime is acceleration. If you have acceleration already, if you want to find out the velocity, take the integral. If you want to go to the R function, take the integral. So in this time, you are going to take the integral of each one so that you can find out the velocity and the R function. Try those two, okay? So it's pretty much a back and forth between differentiation and integral to find out all the velocity, acceleration, and R vector, things like that. So last concept, I'm not going to do this one too long. This is a pretty short topic today. I'm going to talk about the last one, tangential and normal components of acceleration. So in studying the motion of a particle, it is often useful to break the acceleration down into 2 components. So what I'm saying is, in this image, you have a tangent vector and you have a normal unit normal vector. So they're creating 90. And then what does it mean? Tangential acceleration and normal component of the acceleration. This is the another way to find out the acceleration of the tangent line, acceleration of the normal line. So we call this as AT. So if you have acceleration based on the tangent line, we have AT. Acceleration based on the normal, we call AN. So this is the tangential acceleration and normal acceleration. So here is the formula. This is acceleration on tangent vector. So this is a T. And then acceleration on normal vector. Because each vector you can find out the acceleration. So here is the formula. You're going to find out the R prime times R double prime divided by the magnitude. And then AN is going to be the cross product divided by its magnitude of the first derivative. So I'm going to do this work. So I'm going to write that. So in this question, literally we are using that formula. We have R vector. Find out both the tangential, normal. So let's find out the tangent, R prime T dot product double divided by magnitude. So we have R prime will be 3T, 2T, 1. R double, what are you going to get? 3, 2, 0. So therefore, what you're going to get? Am I correct? Oh, I have a mistake. 3T second power 2T. So this one's, it's going to be 6T. Okay, we have R prime, R double prime. So to find out the tangent, the dot product. So R prime T dot R double prime T, 3T second, 2T1 dot 6T 20. We know how to do the dot product. 18T third plus 40 plus 0. So this is going to be your dot product, 18T third plus 40. The dot product gives you the outcome as a scalar. Now we need to find out the magnitude. So let me minimize it. So here, magnitude of this, I'm going to move this one a little bit here. And then this is going to be 9T to the 4, 4T to the second plus 1. So this is the magnitude. So therefore, AT, the acceleration on the tangent line will be 18 T to the third, 4T over 9T to the 4, 4T to the second plus 1. That's the answer. Last one, the normal acceleration on normal vector. So AN, it's going to be cross product, those two, and divided by the same magnitude of the velocity. So we already know. So let's do the cross product. This is cross product. So R prime, we know I, J, K. R prime, 3T to the second, 2T1, and then R prime 6T, 2, 0. So once you do that, let me minimize it. So it is going to be I cross 0 minus 2 minus J 0 minus 60 plus K 60. So let me bring this one here. We have a 60 second minus 12T to the second. So therefore, minus 2I plus 6TJ minus 6T to the second K. So this is going to be more likely -2, 6T, -60 to the second. That's the cross product. Now what happened? we are going to find out the acceleration on normal vector. So the magnitude r prime times r double prime, that would be 4 30/60 second, 30/60 to the 4. And then we already know what this one, the numerator, we already found that here. So therefore, the acceleration normal will be 4 plus 30/60 to the second plus 30/60 to the 4 divided by 9t to the 4, 4t to the second plus 1. So we have a both answer, A, T, A, N. And then they actually ask you find out the number at the origin. What are you going to do? So if you want to find out the last answer, I'm going to copy this here. And I'm going to copy this here. What happened? You're going to plugging in t equal to 0 so that you can find out AT when 0, what happened? Everything is a 0. AN, when t equal to 0, you should get 2. So that's your final answer. Okay, at the moment, you can find out the acceleration. So that's all about it. So 3.4, I'm not really talking about a lot of things. So we definitely talk about how to find out the velocity, acceleration, speed on the space. And then what that means, tangential and normal acceleration, that's the acceleration on that line. Okay, so there's a 2 formula. So you can find out that information in 3.4, very short topic. This one, we already practiced it, so you can try yourself. So 3.4, it's a short video. You can finish all the quizzes and feel free to email me if you have any question. And then please, if you have any Q&A, participate in the discussion board as well. I will see you guys in the next video. Thank you, everyone. Bye-bye.